Hi, welcome to my first Quideo. We're going to be covering chapters 1 and 2 of the textbook. Let's start with the basic question. So, in 1993, Forbes magazine reported the age and salary of the CEO of each of the top 59 small businesses. Then it gives us a table of the salary data rounded to the nearest $1,000. Immediately, we can realize that 21 is going to be our minimum value, and then this number is going to be our maximum value. So what it asks us to do is to construct a histogram for this data, then describe the shape, center, and spread of the distribution of the CEO's salaries. Then it asks to find any outliers. So the first thing it asked us to do was to construct a histogram. Now remember, when constructing histograms, they usually have between 6 and 10 bars. The bars touch each other, and they are grouped by nearby values. The graph is always quantitative data. For part A, I have drawn the histogram. You can see the way I grouped them along the bottom by salary and the frequency along the top bars. Part B was to describe the shape, center, and spread of the distribution of the salaries. Now remember, when describing the shape, it can be described as skewed left, which looks like this, with the hump on the right, opposite of what you would think. Skewed right, where the hump is on the left, opposite as you would think. Approximately normal, where it's a bell curve. Uniform, it looks like this. And bimodal, there should not be a T there, has 2 bumps. When describing the center, the mean is used for approximately normal graphs. And the median is used for skewed right, skewed left, uniform, and bimodal graphs. When describing the spread, use the standard deviation for approximately normal graphs if you can. And when describing the spread for everything else, use a 5-number summary. So for the answer for part B, in describing the shape, center, and spread, I said that in 1993, Forbes magazine reported the salaries of 59 small businesses and found rounded to the nearest thousands. The distribution of the salaries is skewed right. As we can see from the graph, it is skewed to the right, with the tail end going towards the right. The center of the distributions of the salaries can be defined as the mean, which is 350, and remember that is in $1,000, so the 350 would be here-ish, which looks about right on our graph. The spread of the salaries can be described using the 5-number summary, which has a minimum of 21, quartile 1 of 242, a median of 350, a quartile 3 of 543, and a maximum value of 1103. Part C asks if there's any apparent outliers. Remember that outliers are either above the 3rd quartile or below the 1st quartile. We use a formula 1.5 times the interquartile range. Remember that the interquartile range is when you subtract the 3rd quartile value from the 1st quartile value. To find the upper cutoff, you simply add the value for the 3rd quartile plus the formula, and to find the lower cutoff, you subtract quartile 1 from the formula. Underneath, I worked out the problem. This number represents our lower cutoff, or anything below the 1st quartile, and this number represents our upper cutoff. So anything above this value would be considered an outlier. Oh, remember that number that we saw earlier that we pointed out as being a high value? Well, that number is actually an outlier. Okay, question 2 is a slightly more advanced question. It reads, in 1964, a published paper provided chest measurements in inches of 5,738 Scottish militiamen. And then there gives us a table of the values. So it has the chest size over here in inches and the frequency or count over here. It wants us to A, make a histogram of the distribution. Then B, describe the shape, center, and spread of the chest measurements in the distribution. It also wants us to consider why the information would have been useful. So if we take a look at the histogram, we remember that the histogram are usually between 6 to 10 bars, touch each other, and group by nearby values, and they always have quantitative value, or data. So for part A, the histogram looks like this, and it appears to be approximately normal. with this being one value which is not represented very well on the scale. The x-axis is in chest measurements in inches, and the y is in frequency. Part B wants to describe the shape, center, and spread, and why this information would be useful. Here I've provided a detailed explanation. The 5,738 Scottish militiamen chest measurements form a distribution that is approximately normal. The center of the chest measurements is described in terms of mean, which is 39.8 inches. Okay, so how I found the 39.8 inches is I found it by multiplying the chest size in inches with the count or frequency and then adding each of the data points together and dividing by the total. The spread of the data can be described as having a minimum of 33 inches and a maximum of 48 inches. The information would be helpful so you know the average, mean, or median of the man's chest size, which could make creating uniforms for the Scottish Army much easier. For the third question, the AP question on the back reads, as a part of the United States Department of Agriculture super dump cleanup efforts in the early 1990s, various sites in the country were targeted for cleanup. 3 of the targeted sites were River X, River Y, and River Z, and they had become contaminated with pesticides because they were located near abandoned pesticide dump sites. Measurements of the concentration of aldrine, a commonly used pesticide, were taken at 20 randomly selected locations in each river near the dump sites. It gives us a box plot below that displays a 5-number summary for the concentrations in parts per million, ppm. Here you can see River X, River Y, and River Z with concentrations along the x-axis. It wants you to A, compare the distributions of the concentration of the 3 rivers. B, it gives you a set of data for the 20 concentrations in River X, and I want you to construct a stem plot that displays the concentration. Part C wants you to describe the characteristics of the distribution of the concentration in River X that can be seen in the stem plot but not in the dot plot. So let's take a look at part A. Okay, so when comparing the distributions of the 3 rivers X, Y, and Z show the concentrations in parts per million at 20 random locations in each river. Comparing the medians of the dot plot, the median for River X is higher than River Y and Z. The maximum value for the concentrations River Z appears to be closer to the medians of River Y and Z. That should say X, River Y and X. The spread of the River X, along with a large interquartile range, we know interquartile range is when you subtract quartile 3 from quartile 1, makes it seem like it has the most variability. The size of the 3 box plots vary. The shape of the 3 box plots varies in that River X is skewed to the right, River Y is approximately normal, and River Z is skewed to the left, as you can see in the picture. Part B wanted us to make the stem plot. Now remember, use placeholders when values are not there. In this case, it would be the 6. The whole numbers go on this side and the decimals or tens go on the right. And the commas I added are unnecessary. Okay, as we can see, there's a gap right here because there's not a value of 6. So that kind of answers part C. The stem plot shows the overall shape of the distribution with it being skewed to the right. However, the stem plot shows the gap in the data between 5.6 and 7.3. That was not evident on the dot plot. Now remember, graphs usually point to outliers. However, on the dot plot, or on the box plot rather, you cannot see a gap in the data.